Right now, as you look in the mirror, you are not seeing yourself. You are watching a ghost, a version of you that no longer exists, frozen in a moment that has already passed. Your brain insists it's real. Physics says otherwise. The speed of light is not infinite, and because of that single fact, every reflection you have ever seen, every glance in the bathroom mirror, every quick look in a car window, every selfie you've ever taken, captured something that was already dead by the time you saw it. This is not philosophy. This is not metaphor. This is measured, proven, unavoidable physics. And once you understand it, you will never look at yourself the same way again. Here is a question no one ever thinks to ask. How old is the face you see in the mirror? Most people assume the answer is obvious. It's your face, right now. Live. But science has quietly, methodically, and completely destroyed that assumption. Light, the very thing that allows you to see anything at all, travels at approximately 299,792 kilometers per second. That sounds impossibly fast. And across cosmic distances, it is the defining ruler of time itself. But here, in the ordinary world, in the tiny gap between your face and the mirror across the room, light still takes time. A tiny, measurable, real amount of time. Your reflection is not you in the present. It is you in the past. And no matter how fast you move, how close you stand, how desperately you try, you cannot close that gap. You cannot catch up to yourself. The person in the mirror is physically, mathematically, scientifically impossible to reach. In the next few minutes, we are going to take this idea apart, layer by layer. We'll start with the physics, move through neuroscience and perception, then land somewhere far stranger than you expected, at the edge of what identity, time, and reality actually mean. Stay with me, because by the end of this, you won't just see the world differently, you'll see yourself differently. Let's start with the science, because the numbers are genuinely mind-bending. Light travels at 299,792,458 meters per second in a vacuum, inside a mirror, through air, then bouncing off a reflective surface. It moves slightly slower, but still extraordinarily fast. Fast enough that in 1 second, light could circle the entire Earth more than 7 times. And yet, it still takes time. If you stand 1 meter away from a mirror, a perfectly ordinary distance in any bathroom, the light from your face travels 1 meter to the mirror, then 1 meter back to your eyes. That's 2 meters total. At the speed of light, that round trip takes approximately 6.47 nanoseconds. 6.7 billionths of a second. That sounds negligible, almost mockably small. But here is what that number actually means. In that 7 nanoseconds, your heart has beaten fractionally forward. Your neurons have already begun firing new signals. The cellular processes in your skin have continued aging. The atoms in your body have shifted. The version of you that sent that light to the mirror, it no longer exists. You have already moved on. But here is where it gets truly unsettling. What if the gap wasn't nanoseconds? What if it was much, much longer? To understand why 6.7 nanoseconds matters, we have to zoom out, literally, to astronomical scales. The sun is approximately 150 million kilometers from Earth. Light from the sun takes 8 minutes and 20 seconds to reach us. This means that right now, if you step outside and look at the sun, never directly, of course, you are seeing the sun as it was over 8 minutes ago. If the sun were to suddenly vanish, we wouldn't know for 8 minutes. We'd still feel its warmth, still see its light, still exist in a solar system that had already fundamentally changed. The nearest star beyond our sun, Proxima Centauri, is 24 light years away. The light reaching your eyes from that star tonight left its source over 4 years ago. You are looking at a star that might not even exist anymore. And the Andromeda Galaxy, visible to the naked eye on a clear night, appears to us as it was 537 million years ago. When that light left Andromeda, Modern humans didn't exist yet. Homo sapiens as a species was still a distant biological possibility. Every act of seeing is an act of time travel. Every photon that enters your eye carries information from the past. Now bring that principle back to the mirror, back to the bathroom, back to you. The delay is smaller, but the principle is identical. You are never seeing the present. You are always seeing the past. Here is where physics hands the baton to neuroscience, and things get even stranger. The human brain processes visual information with a delay. The light enters your eye, stimulates photoreceptor cells in the retina, converts to electrical signals, travels along the optic nerve, reaches the visual cortex at the back of your skull, and is then interpreted, assembled, and rendered into the image you experience as seeing. That entire process takes between 80 and 200 milliseconds, roughly a tenth of a second. So the physics delay, 6, 7 nanoseconds, is almost nothing compared to the biological delay, up to 200 milliseconds before you are conscious of the image at all. But here is the truly unsettling part. Your brain doesn't show you the past. It performs a live reconstruction, filling in gaps, predicting motion, smoothing over inconsistencies. Neuroscientists call this predictive processing. Your brain is not a camera. It's a storyteller, one that is constantly writing a version of reality slightly ahead of what your senses actually received. What you see in the mirror is not your face. It is your brain's best prediction of your face, assembled from light that is already old, filtered through neural hardware that takes time to process, and rendered into a seamless illusion of right now. Right now doesn't exist in your perception. It never did. And if that's true for your reflection, what about everything else you see? There is another layer to this that pure physics makes even more final. Mirrors do not show you what you look like. They show you a left-right reversed image of yourself. This is why when you raise your right hand, your reflection raises its left. Every person who has ever looked at you sees a version of your face that you have never, ever seen with your own eyes. You have never seen your own face in real time. Not once. Not ever. Photographs are also delayed, captured in the past. Video has encoding lag. Even live video streams carry a processing delay of milliseconds to seconds. The face you believe you have, the mental image you carry of yourself, is an averaging, a collage of thousands of past glimpses, all from the wrong angle, all from the past, all slightly distorted by the reversal effect. Scientists who study body dysmorphia and self-perception have found that humans are uniquely bad at accurately perceiving their own appearance. We remember ourselves as more symmetrical than we are. We smooth our own features in memory. We carry a ghost of a face that never quite matched reality. The mirror doesn't show you your face. It shows you a construction, delayed, reversed, filtered through biology and expectation and memory. You have never seen your own face. Not the real one. Not in real time. Not from the right angle. Never. So who is that person looking back at you? Here is the question physics quietly forces us to ask. If every moment of perception is a moment from the past, if there is no true now in human experience, what does that mean for identity? The philosopher Derek Parfit spent his life asking a version of this question. If your body replaces most of its cells every 7 to 10 years, if your memories are reconstructions rather than recordings, if your self-perception is a delayed, reversed, neurologically filtered approximation, in what sense are you the same person you were yesterday? Physics has an answer, and it's more radical than philosophy. In the block universe model, one of the leading interpretations of Einstein's theory of relativity, all moments in time exist simultaneously. The past is not gone. The future is not unmade. Every moment is equally real, equally present, just located at different coordinates in space-time. That means the version of you from 6, 7 nanoseconds ago, the one frozen in your reflection, still exists. Not here, not now, but somewhere in the geometry of space-time, that moment is as real as this one. The stranger in your mirror is not a shadow or a trick. They are a real version of you, located in a slightly different coordinate of reality, impossible to reach, forever preserved in the fabric of the universe. You will never meet them. The gap between you is not distance. It's time itself. And time, as far as physics is concerned, runs only one way. So the next time you stand in front of a mirror, consider this. The face looking back at you has already moved on. It sent its light signal and vanished into the past before the image ever reached your eyes. Your brain assembled it from fragments. Your memory colored it with expectation. Your nervous system delivered it 200 milliseconds late. And that version of you, the one you spent your whole life looking at, is reversed. Approximate. Ancient by nanoseconds. An echo you've mistaken for a source. The real you is always one step ahead, moving, changing, aging, becoming, while your reflection chases from behind, never quite catching up. Physics doesn't just tell us the universe is strange. It tells us that the strangest thing in the universe might be the ordinary act of recognizing your own face. You are not who you see. You are always slightly beyond the image, 1 nanosecond ahead, 1 heartbeat forward, 1 moment deeper into a present that perception can never quite reach. The person in the mirror is a stranger, a beautiful, scientifically precise, forever unreachable stranger. And they are the closest thing to you that will ever exist.